So good morning, everyone. This is Amber speaking. Today, I will guide you to explore the geo-intelligence with AI technology. So before talking about AI, let us first understand the geo-intelligence. We proposed the pyramid of the geo-intelligence several years ago. The bottom of the pyramid is the geo-visualization, which is the first view effect that many industry concerns when they start to using GIS. The second level is the geo-decision, and the third layer is the geo-design, and the top is the geo-control. The complexity is getting higher from the bottom to the top, and the maturity is from low to high. And as an important driving force of the geo-intelligence, GIS software has been continuously innovating technology and evolving the geo-intelligence. So in recent years, GIS software has developed rapidly. We already have 5 key technologies in SuperMap GIS 10i. And the first one is a cross-platform GIS, which can make GIS software run on different operating systems and CPUs or database and different terminals. The second is cloud-native GIS, which can better play the role of cloud. And the third one is the big data GIS, and the fourth one is the new 3D GIS. So AI GIS is added in the last year. We call the whole system called BITCC. So what is the core values of the AI? The core value of the industry revolution is to liberate human beings from repetitive physical labor. And artificial intelligence is to liberate humans from repeated mental work. Actually, AI came into being in 1956, which caused by small clinics. However, in the 1970s, when it reached a very low point, it found that artificial AI was very beautiful, but it's hard to realize. So machine learning has reached a new peak since the 1980s, but it hasn't been able to do so much since the 1990s. But however, after 2000, after the development of deep learning, it has been to a new height, especially the famous AlphaGo with the human players. So now AI is the most popular topic. So here is our AI technology system. What is AI GIS? The basics of the AI technology is the data, and the second layer is a library, which includes the sample data and the training models. The third layer is the framework of AI. Is a framework of AI algorithm. Then the top is the functions of AI GIS. Here are 3 main parts. First is GeoAl, and the second part AI GIS, that means AI helps GIS software to improve its functions. And the third part is GIS for AI. And let's analyze the technical system. So the data layer is the basis of a AI GIS technology system, which is mainly used to store and manage different types of data, such as original data, vector data, grid data, 3D model, in the file, mainly including the file data, such as CSV or TIFF image, and the relation data. Relational data such as 2D data stored in PostgreSQL or in other database, and no circuit data, that means the distributed data, such as large-scale data stored in distributed environments. And this data provides the original support for spatial learning or spatial deep learning in upper layer. And this is a technical system analysis for library. In general, the original library is used to store basic geospatial data information, and it can clean the data and this data can be cleaned and transformed into sample database. And the richer the data in the original database, and the better quality of the model reasoning. And so the sample database is to transform the geospatial data into sample data that's suitable for machine learning and model training, and it also provides the unified API for sample data reading and writing. Then next step is a model. Model library consists of the model files and the model parameters. Model file defines and describes the model structure through text or code or other ways. And the model parameters used to store model information after training, which can be used for multiple rounds of iterative training or published as a model surveys. And let's see, this is talk about the framework. The framework is the guarantee of the ability of AIGs. On the one hand, the framework has some classical algorithm, but on the other hand, it can quickly expand and derive new algorithm and through these frameworks. Let's first talk about the TensorFlow. TensorFlow is an open source and Python-based machine learning framework, which is developed by Google. It has a relatively complete ecosystem, which is supported in mobile terminal and the server side. It includes very rich applications in image classification, audio processing, NLP, and other scenarios. It's currently the most popular machine learning framework, which is also suitable for AI product construction, and our SuperMap AI functions is also mainly developed based on this. And next one is Keras. Keras is a very high-level neural network API. It's written in Python, which can run with TensorFlows as a backend. And the Keras focus on fast experiments. It's very user-friendly for academic researching, and it's able to transform your idea into experiment results. And next one is PyTorch. PyTorch is a Python version of the Torch. Torch is a deep learning framework released by Facebook. It supports a dynamic calculation chart, which is more flexible and convenient to use. It also has a large number of model resources supported, especially suitable for small or medium-sized machine learning projects and deep learning beginners. And the last one is Spark Machine Learning Lab. This is Spark's machine learning library. It aims to simplify the practice of machine learning process and expand it to big scale. Machine learning lab consists of some general learning algorithm and tools, including classification, regression, clustering, collaborative filtering, and dimensional reduction, and as well as some underlying primitives and high-level pipeline API. Also, SuperMap GIS uses Spark as a big data engine to do some distributed storage and distributed calculation. So that's the part of the framework. So what is we have talked AIGs have three main functions: GeoAI, AIGs, and GIS for AI. And the GeoAI is a series of functions which SuperMap innovated for solving some geospatial problems and developed based on the basic theories and algorithms of AI, such as statistics, machine learning, deep learning. So it focuses on spatial data processing, spatial analysis, and data mining or modeling. And GIS for AI is to optimize the GIS software performance based on AI technology. And AI for GIS, GIS for AI is to GIS can provide AI more ability in spatial visualization and the spatial analysis and further process and analysis with AI results in GIS softwares. So let's talk and introduce the three main functions one by one. The first one is the GeoAI in short. And GeoAI is a model and the algorithm of spatial analysis and processing with AI. And so usually AI in artificial intelligence have three kinds of weapons. First one is statistics, and the next is it's called continuous machine learning. Includes some supervised learning, semi-supervised learning, unsupervised learning, and the next part is deep learning, which is a part of the machine learning. It's also an algorithm that allows computers to learn by themselves. So from AI to GeoAI, at first of all, we see that the combination of the statistics and the spatial and produce the spatial statistics, which is very good foundation for machine learning and deep geospatial machine learning and geospatial deep learning. So what is spatial statistics? Spatial statistics is a series of statistics methods to analyze spatial data. It's different from the independent distributed hypothesis in the classical statistic research. Spatial data has some typical characteristics such as spatial autocorrelation and the spatial stratification and heterogeneity. Therefore, the process of the generalizing the spatial characteristics is very necessary, and spatial statistics have a lot of GeoAI operators. This algorithm has been achieved before, like it's just geospatial distribution, interpolation regression, and the geospatial distribution. Yeah. So here is an example that about the spatial autocorrections. The environmental factors that identified by spatial pattern of disease. We can analyze three potential factors that can infect the disease incidence, like DEM or soil type or water shadow zoning. According to the calculation, correlation calculation, we found the water shadow zoning dominates the spatial pattern of the disease incidence. And the next is the spatial machine learning. And so spatial machine learning is an algorithm that can let computers learn by automatically. Spatial learning mainly includes the clustering or regression algorithms such as spatial density and clustering forest-based classification. And at present, we provide the clustering analysis, classification, and includes the forest-based classification. Regression includes the GWR, geographically weighted regression, and also forest-based regression. These operators help to solve the natural and the social problems, such as the exploration of commercial hotspots and analysis of the residential area agglomeration, the identification of the suitable living areas of animals or plants, and the prediction of natural disasters, and the prediction of the housing prices in different urban areas. So in order to support spatial big data computing, machine learning algorithm and distributed computing are effectively combined, which can greatly improve the performance of spatial machine learning. So first one, let's say one case about hotspot analysis. This case shows the distribution and aggregation of the business POI in one district of Wuhan city, and it combined the attribute analysis of business situation, such as business turnover, the hot area, and the cold spot of business distribution, which can reflect where it is more suitable for business activities. And this one is a spatial density clustering. In this map, it can show where is most density area in Beijing. And this one is cases of GWR, and this case is the incidence rate of NTD, narrow tube defects. It's an analysis of the its influence factors. So we're looking for what these diseases are related to, and this is application in pathology. And this is a case about predict the housing price that are impacted by infrastructure. It's use of forest-based regression. First, we can obtain the housing price data of the whole city and calculate the influence by traffic or education, medical or other infrastructure. For example, the distance from facilities and number of the infrastructure within a certain distance. So take this as an explanatory variables that run the forest-based regression model for the house price, and after the modeling, you can predict the value of the other properties. And this one is the prediction of Anopheles distribution. So this one taking the weather temperature condition as a plan, as explanatory variables, like the temperature range, the lowest temperature in the coldest month, and the average temperature of the hottest season, and then taking whether it's suitable for the growth and the reproduction of the Anopheles as a dependent variables. So the forest-based classification model is used for modeling. After the modeling, the classification prediction of the weather other locations are suitable for the growth of the Anopheles can be carried out based on this model. So we talked about spatial, geospatial machine learning. Next is about geospatial deep learning. At present, deep learning are already represented by convolutional neural network is mainly used because deep learning technology has shown good application in computer vision and image understanding. So SuperMap applies this in field of remote sensing image analysis to improve the efficiency and the accuracy of the image processing. And the SuperMap GIS-10i have added algorithm for image analysis like object detection, scene classification, binary classification, and we also apply in 3D analysis like extracting the building footprint from the oblique photogrammetry or DSM data. Here is a cases that object detection, and this is application in Thailand, and we can extract the palm trees and add a palm tree from the images, and then we can add palm tree models, 3D models within 3D thing, and also can detect the palm trees with good growth, with better growth. And this is binary classification. You can extract the building footprint from the remote sensing image. Then you don't need to draw the polygons of the buildings one by one. And this is a land use classification. You can achieve the land use classification automatically, and you don't have to. And the accuracy is better than the traditional classification. So actually GeoAI and many algorithms of GeoAI involves the large scale data. So we need to use a distributed algorithm to improve the performance. You can see this yellow algorithm. They are built with a distributed algorithm, which can support the distributed computing. So here is the cases about spatial density clustering by distributed computing. For the blue line is that it's computer equipment. It has 24 cores of CPU, and the red one is also the same, but it's with the distributed algorithm. It also has the 24 cores, but the speed is increased by 22 times. So there are some steps in the calculation during machine learning. So the first step is to select the operating model according to your data. So what's the workflow of the GeoAI? Let's talk about it now. The workflow has 3 steps. The first one is data preparation, including the data collection and the data storage, especially the preparation of sample data. Then the second step is the model building, includes the model training and evaluation, transformation, and model updating. And the final step is the model reasoning and the model application. And so the whole process requires many iterations to get more practical results. And this is product metrics for GeoAI tools. That's component GIS that SuperMap iObjects Python and iDesktop X fully supported the whole process. And the SuperMap iServer data science service, but SuperMap iServer machine learning service can achieve the model application. And this is SuperMap iObjects. So iObjects Spark is in charge of the distributed machine learning and the distributed storage management support. And SuperMap iObjects Python is in charge of the machine learning functions, operators, and the working flow and other support. So this is the interface of SuperMap AI Desktop X. Could find the tools in toolbox image analysis. First step is create the training data, the sample generation, and the model. The next step is model training. After that, you can select the functions that you want to do: object detection, binary, and classification, multiple classification, sync classification. And then this is SuperMap iServer, and that distributed analysis service includes the distribute and spatial analysis and the related machine learning operators and distributed analysis functions. And the machine learning service focuses on the presentation of the spatial deep learning, including publishing the trained model into web service and providing the used AI GIS functions. And the data science service, it's under the environment Jupyter. It can integrate the SuperMap spatial data and science database with a third-party data science module, which is not only can support the workflow of deep learning, but also can support the related spatial learning functions. So, in addition to the Python library of SuperMap, the data science service has built in the third-party library to provide a more comprehensive and powerful data science capability, and which is also provided by notebook editor. And so this is data science service, and what you see is what you get. So that's all for the GeoAI. Now we can go to the AI for GIS. AI for GIS is to optimize the GIS functions based on AI technology. For example, AI technology is applied to some traditional GIS business to achieve the intelligent evolution of GIS software. At present, SuperMap mainly provides four functions. The first one is AI attribute collecting, and AI map survey and mapping, AI cartography, and the AI interaction. So first one, let's see, the AI attribute collecting. So here is an example. And this is a case in our digital city management system. The case is we found some illegal cases or some problems that we need to record. So this case is about the parking violation. So once we have to take a picture of this car, we can recognize it's a car, and we can recognize the blue license plate number and the color. So we don't need to fill this information manually, and this system can help to fill all this information automatically. Also includes some advertisement posters. It can fill the information and update the location. And this is some trash illegal disposal. And you also can record the city of element. Then you can, like, say here you can see it's so well, okay. Well, then you can locate it and update it to the system. Second part is AI survey and mapping. This is the case for indoor mapping. Indoor mapping has a problem, but the first challenge is the AI positioning because GPS doesn't work well in indoor environments. So in this system, we will use the IMU and vision positioning because our smartphones has equipment of IMU that will improve the indoor positioning accuracy. Like say here's an example when you when you walk through in this building, you will get the track of your path, and that can fit with indoor maps. So this technology, the IMU and the vision positioning technology has been applied in our AR plus AI survey and mapping functions. Like say this is a case, if you want to measure the one shop in this shopping mall, and you just walk through it and click some corners, then you will get the shape of this shop. So what's the app if you want to try these functions? How can you do this? So we have SuperMap AI tablet. So you can download this application in your mobile application store and try the AI mapping functions. And it's very convenient for indoor surveying and mapping. One is very high precision is not required, but the precision can be 1%, like 1 meter, only have some 10 centimeters error. And the next part is the AI cartography. What is the AI cartography? So when we usually when we do the map, when we do the styling of the maps, we will cost a lot of selecting the colors or selecting the icons of the features. So what AI help on styling? We could like this. We could select a style picture and extract the main colors by K-means algorithm. Then we can make a match, then apply these colors in our map. Let's see some example. Here we could find some pictures, and we can easily immigrate the color style of the pictures to the map. Maybe the results, this result is very creative, but sometimes it cannot meet the requirements of the geometric works. But it doesn't matter. We can do small correction based on the results. Yeah. So what we can do? So And when we are processing the map, we want to adjust the styles. Usually, when we took a picture, by our smartphone, we will think about some Photoshop, some beautify apps. So can we beautify the maps, beautify the pictures? Yes, like a Photoshop, we provide some functions like Photoshop. You can adjust the highlight length and the contractness and the saturation like Photoshop. And the next part is the AI interaction. We all know the navigation voice that also it's provided in our mobile GIS, that you can do some operations like hide the map and type some information or change the color. And also then you can control the map use your hand gesture, then you can see different gesture means different order. Here, let's say we can use different hand gesture to remove the map, zoom in or zoom out. And you also can adjust the lightness of the map. So you can add more hand gestures for different orders. Yeah, it also can be used for 3D scene. Can move the scene by your hand, or you can adjust the camera views. And you can also rotate the 3D scene. So let's say, that the previous two cases is when you can use a hand gesture in front of your desktop to do some operations. But when there is a dashboard, it's very far, the big screen that's far away from our hand. So then we can use our posture to do some operations. And like say here, we are facing a big screen, a dashboard on the wall. Then we can use our body language to zoom in, to move the map, to do some changing operations. So that's for AI interaction. The next part is the GIS for AI. So on the continuous development of AI intelligence, it also needs to absorb and integrate with other technologies such as GIS. So GIS can give AI more ability of the spatial visualization and the spatial analysis. Yeah. The first part is spatial visualization for AI. Like say this case is the visualization of traffic situations that cameras displayed. So the camera identified the situation, and we can present the visualization, the identified results on the map. And it also can be used for city management and achieve the visualization of city management cases. When we record this data into system, we can make this data displayed on the map and where it is to show where the case it is, and we can know the distributions of the legal cases. And also here are some spatial analysis for AI. Here is cases using that geofence. The right polygon is a geofence for detecting the legal cars. And when we diagnose this position, something we can record the cars that into these polygons. And this case is about vehicle route tracking. So we only just need to input these car photos, then we can track all the cars' route, especially for the management of the taxis. And also it can be used for some spacious cars to so we talk about the AI GIS technology system. So now it's the product system of AI GIS SuperMap, and which was proposed a new Python for spatial data this year, including machine learning framework and So this is all the basic AI framework and some GIS components that support the machine learning and deep learning. And on the top is the server side, which provides two sciences, that's machine learning science and data science service. Then on the edge is an iManager, and on the top is a various terminal, like the web terminal, and the mobile terminal, and the PC terminal. So with the technology and the product system, this is our AIG's product system. So here's AI product function matrix. And we can see that SuperMap AI Desktop X supports the full functions. So if you want to try some AI functions of SuperMap, firstly you can download a SuperMap AI Desktop to try all of these functions. And if you have other special requirements in server side or in component side, on mobile side, you can use our iMobile, iClient, iServer, and objects. If you want to run the AI functions in your own laptop, and this is a recommended environmental referee about your GPU, CPU, and the graphic card, the disk. Now I would like to show you some applications, some cases. Say this is image classification. In computer science, we know this, we can diagnose, identify this a picture of the cat. And in GIS, this is the image of an airport area. And so we also can see that this is a case in smart city management. We can classify something like broken road, illegal advertisement, manhole cover damaged, and garbage dump. And object detection. So in computer science, we can identify the cats or the dogs in these computers in different objects. And in GIS, we can detect the airplanes from the image of the airport. And also that you can detect other interested objects like helicopter, bridge, or swimming pool, cars, tennis. Yeah. And here is a targeted monitoring application we call Smart Eyes. It's to detect the land violations. Usually, the traditional way we will use personal inspection with massive reports and analyze that with remote sensing image. So it will cost more time, and the accuracy was low. And so, but now we used to we integrate AI technology to analyze the videos or pictures that are captured by the camera. And we also can show the camera's location on the map. This is called the video surveillance system. And so deep learning, and we can we can identify the land violations and also know its location. So this is a screenshot of the system. The right point means the camera's location, and we can see every camera's real view. And based on the massive video data or image data, we can identify the excavators. So deep learning automatically then manually combine with the map system to make the final determination. And this is the another screenshot that means the alert. If the system detects any dangerous operations, and it will send the alert. It will trigger the alert automatically. And here are more applications about video target detection. This is used for traffic industry. You can achieve the real-time object detection. So the cameras videos, and you can detect the bench and detect the phone. Also, you can show its all the information. Also, you can detect you can recognize the car color, the car plate number, and the plate position of the car, and the category and area of this car. X-ray is another object detecting. In computer science, and you can detect every human's track. In GIS industry, then you can extract the vehicle tracks from these videos. And here is some, you can calculate the traffic volume. So this real-time videos. And this is some semantic segmentation. In computer, we can segment people, cars, and roads. But in GIS, we can segment different classifications: land or residential area, buildings, rivers, residential area to use, achieve the land use classification. And also see some instance segmentation. You can detect each building. Also, you can extract the road. This shows the images, then you can detect the illegal river construction. So that's all the case I want to share with you. Through this presentation, we could see geointelligence really involves with GIS. So the future is only limited by our imagination. So that's all for this presentation. Thanks for your time.